Hello and welcome back. What type of information in images can we use for image and video segmentation? In particular, I want to discuss a bit about edges and regions. Let's just look at one very nice image of a flower. We are going to assume that we want to segment out this flower. We want to separate the flower from the background. There are certain regions like here where there is a very clear boundary. So we have discussed, for example, edges and gradients. Remember, the gradient that we represent in this form, it's just nothing else than the vector of the derivative in the image, derivative of the image in the x direction, derivative of the image in the y direction. We talked about how to implement that a few weeks ago. For example, a derivative in the x direction we could do with a simple filter of +1, -1, and -1. Now, if we take this derivative and we compute the magnitude of the vector, because there are very clear differences in both sides of the flower in this region, very clearly that will help us to separate the flower from the background. And we're going to see very often using the gradient as part of our image segmentation algorithms. On the other hand, we see here, we might also get gradients, but we don't want these gradients to be part of the segmentation. There are differences inside the flower that we don't want them to appear. So clearly, we can use these borders, these edges, or these gradients. We don't want to use the ones inside, and that makes our life a bit more difficult. But it also tells us that we are not really looking for a uniform region inside the flower. If we were to put that as a constraint in our segmentation, we will not get very far, because inside the flower things change a lot. We're actually looking for big differences between the flower and the background, and therefore edges are going to be very important to segment this flower, as we are going to see in the future videos. But let's just look at a slightly different image. Look at now at this image. We clearly see a ball here, although they're basically, let me just get the pen, there are basically no edges here. We see the ball, but we don't see any edges. But we understand the shape. So here, we're not going to be able to use edge information. There are no edges. If we were to compute the gradient in this region, here, any pixel here, we will try to compute the gradient. That gradient will be 0 or very low and won't help us to find the border, to find the object of interest. On the other hand, we could use shape. We could use regions. Okay, so we could try to understand that this is kind of a uniform region, kind of a uniform region. And actually, we can use that fact to basically help us obtain the segmentation. Let's just see the edges of this image to further illustrate that edges won't help in this case. So here I took the green channel of the color image that we just saw, and I computed, in this case I used MATLAB, I computed edges. So we see some spurious edges. Those don't bother us too much. We learned in the past how to get rid of them, for example by pre-filtering the image, removing the noise before. We get nice edges here, but no edges here. This is a tiny edge because there is probably a very weak boundary here, but no edges here. So we will need other types of information in order to be able to segment this ball out of the background. Looks very simple, but edges are not sufficient. What I want to show you in the next videos is how to incorporate multiple sources of information. First, we're going to start in the next video with half transform that is going to help us to integrate shape that we know if we are looking for a line, we can put that into the segmentation or detection algorithm. If we are looking for a circle, like here, we can incorporate that into the algorithm. And we do that with the half transform. I see you in the next video for that. Thank you.